Okay, 8th grade, 7.2, representations of functions. Okay, all you're doing for the warm-ups, you are solving the system by graphing. We did this all last chapter. Solve for y. You'll get your slope and your y-intercept on both of these. You graph them, and where they meet is your solution. Okay? So, for this one, how do I get y by itself? Subtract x. No, leave the y there. So my answer would be y equals negative x plus 3, right?
Yeah.
So I'm going to go to 3, put a dot. And then negative x means I go down 1 over 1.
Yes.
Okay, now for the second one, let's solve that one. So again, I have to move the x by subtraction. Okay, and I'm left with negative y equals negative x minus 5. How do I get rid of the negative on the y?
Divide by negative 1.
Divide by negative 1. So then I'll have y equals a negative divided by a negative is a positive, was the word I was looking for. So you'll have positive x plus 5. So I go up to 5 and put a dot. My slope is up 1 over 1. So where do these cross?
At negative 1, 4.
Negative 1 comma 4. So your answer should be negative 1, 4. Whoops. Alright, so there's your first warm-up. Go do the second warm-up. This one will take not much more effort. It's this one's already solved for you right here.
May you please check my answers?
Yes, I will check everybody's answers. Okay, you need to write the key vocabulary word, the function rule definition. You do not have to draw this picture. If you already did, good for you. Some of you are very visual and it will help you. So the point of this is as a visual as when you input something into the machine being the rule or the equation, you will output an answer. Okay, so everybody look up here at the screen. The point is input. See, they're inputting a negative 2 into the function, which is the machine, y equals 3x. When I input a negative 2 there, it goes where the x is, and I get my y value, which is negative 6. It's just to give you a visual representation. So all I want you to write down is input negative 2, then draw an arrow to the function rule, which is y equals 3x. And then draw an arrow to output, which is negative 6. Do I need to draw that, or do you understand what I said?
I thought I understood. We could do this. We'll leave enough. I'm sorry, that's right. Okay, the output is 5 left. Okay, cute. I don't know how no word.
So I would write the word input, which is negative 2. Draw an arrow, because you're inputting this, into the y equals 2x. What is that representing? What is the y equals 2x?
Function rule.
Function rule, very good. So I would write function rule here. Man, this is all over the place. Function rule. Okay, and then, well, almost a straight arrow. Just kidding. Then I got my output, which is,
Negative 6.
yep, negative 6.
Wait, what?
Wait, negative 4.
I think you did. I think it was supposed to be y equals 3x.
Yeah.
Thank you.
Negative 4.
Excellent. Good catch. 3x. I hate it when it does that.
I don't think you selected it.
I did. So this is a 3. Okay, now I'm going to use my other color. So essentially I'm taking my negative 2 and I'm plugging it in where the x is into the function. And then when I do that, I do negative 2 times 3 to get my output, which is y. Does that help explain it? Okay. For those of you listening, anyhow.
Yes.
Yes, ma'am.
Example 1, put this in your journals. We're going to write a function rule for the statement. The output is 5 less than the input. Okay, so this is words we're going to put into a mathematical equation. So the words are, the output is 5 less than the input. So let's go through this. The output, what would we represent the output with? Y. We'd put the Y. Okay? Is equals. What's 5 less than the input. Let's start with the input. What is X? The input is X, and it's 5 less. So do I have an equation? Y equals X minus 5? It would have to say the words 5 minus X, so then the 5 would be in front of the X. But since this is 5 less than the X, then you have S minus X minus the 5. So you really got to pay attention to the wording.
Because if you put 5 minus X, it would be 5 minus 1.
Yeah, it'll mess it up.
Yeah, well,
So your function rule is
toss it up.
Y equals X minus 5. Okay? It's just an equation.
Oh, no.
It's all right. All right, so let's do B. Shh, put this in your journals. Write a function rule for the output is the square of the input. So again, the output is what? Y. Is equals the square of the input. What's input? X. And what are we doing to it? So you're going to write X squared. Y equals X squared. That's the square root. So that's the opposite. Looks like, no, it looks like a division with a little extra in the front. It's a square root sign. So guys, when you see the square root sign, that's just the opposite of the little 2. It's like going backwards. The square root.
Oh, so what?
Let me show you. So when I tell you, wrong button. So you know how when we're rearranging things and I tell you what's the opposite of addition and you tell me multiplication?
You just said addition.
I'm so tired. Addition, the opposite of addition.
Nice.
The opposite of addition is subtraction. The opposite of multiplication is division. If I am squaring something, X squared, the opposite of squared is square root.
Whoa.
Okay?
What's that do?
So if I square root something that is squared, that cancels out this squared, and you're left with just the X.
Oh, okay. Okay.
That's how you do the opposite of squaring. Or if I want to do the opposite of square root, so if I have the square root of X, then all I do to get rid of that square root is to square it.
How would okay.
How would you know that? I just taught it to you.
No, like if X was actually a number, how would you?
Oh, okay. Let's do that. So if I have
25.
25.
Oh, take that.
So if I have the square root of 25, what do I get?
I don't know.
5 times 5 is
What do
25.
you? Okay.
It's just the beginning of the
Okay? Now, if I want to get rid of this square root, all I do is take this and I square it. So then I do the same to this side to square it. So then that's canceled. And I'm left with 25 equals. Is that true?
I don't sure.
Then I did it right. Yes.
Wait, what?
Why? I never learned that my whole life until
That's
now.
better than 24.
Well, this is about when you learn it.
Oh.
Then why has it been on 25?
No.
Well, you should have learned it a little bit in 7th grade, I guess.
Oh no. We know about that. No.
It's okay. It's all right. We got it now. We're good.
Wait. Okay.
And you'll learn it more. You'll get more of it next year.
Okay.
Okay, any questions? You're ahead of it. Question.
Put the mic on. Can you hear everybody around?
Not quite.
Okay, good.
I hope that.
Like if I shush everybody, it's still on. You guys know that, right?
Oh.
Hello,
hey
online
guys.
people.
Hi, Ari.
I was out.
It's not just ARA. You think I got other people watching?
No.
No, not really.
Rude. All right, go do your try it.
I did it.
Okay, what is the
I
value
don't know.
of y equals 2x plus 5 when x equals 3. So what? Listen. The x equaling 3. Is x the input or the output? Input. So where would I put this 3 in this equation? Where the x is. So I just replace the x with the 3. Write this down. You've done this 100 times already.
I remember doing that.
So plug that in. What do I get? 2 times 3 is?
6.
Plus 5.
11.
So what is my output? 11. Done. Yes, I do. Okay. Go and do triads 2 through 4.
I think it's like oh, let's go like a 2 right in the way. Okay. Oh dear.
Okay, so let's look at this key idea. A function, remember function is just a fancy word for y equals mx plus b equation. Function is just this equation right here. That's all it is. Okay, when you think of function, think of y equals mx plus b. Okay, so a function can be represented by an input-output table. So everything I plug in for x, when I plug in a 1, I get a 3. When I plug in a 2, I get a 4. When I plug in a 5, I get a 3, I get a 5. All it is creating your ordered pairs so you could graph it. Okay, so this is a way to graph it using multiple ordered pairs. Somebody asked the question, do I have to use a table? No. Could I just graph this equation?
Yes.
Yes. I could go up to 2, which is right here, put a dot, and my slope is up 1 over 1, put another dot. Do I have my line?
Yes.
Yes. Okay, so no, you don't have to use a table. All right, let's do the example.
Okay.
Graph the function y equals negative 2x plus 1. Do you want to do the table or do you want to just graph it? So if I have my graph, what is my y-intercept?
1.
So I go up to 1 and I put a dot. It doesn't allow. Big dot. Dot. Okay. What is my slope?
-2.
Negative 2, so I'm going to go down to 1, 2, and over
1.
1, and put a dot. So now I have a slope, or now I have a line. Oh, man. I survived. Okay, so do you have this graphed now?
Sure.
Yeah.
Yes.
That's all it told you to do, right? Graph the function.
Yep.
So solutions to this function would be any point along this line, yes?
Yes.
You understand that?
Yes.
All right, good. I will click and show you. So all they did, you don't have to write this down, just look up here and watch. They chose input values. So they chose numbers. They picked one negative number and then a 0 and a couple positive numbers. Okay, then they solved it by plugging it in for the input, which is x. That gave them their output, which gave them an ordered pair. You need to understand how to do this. You will do it again. Are you watching my screen? Okay. All right, so once they did that, they took all of these ordered pairs and they plotted them and got their line. Again, it's the same line we got, correct? You see how it's the exact same? These 2 points were 2 of the ones we actually graphed?
Yes.
Okay. So you can do it either way, but you need to understand this way to do it. It is more time consuming, that is for sure. All right. Go and do 5 through 7. I was just going to look at it and tell you what part of the summary you need to write. Okay, on the summary, listen. If you have written examples of an input-output table and a mapping diagram and a graph in your lesson, you do not have to write this again.
Okay.
If you skipped these and did not write them throughout the lesson, then do that. All right, go team, go. Example 4. A car produces 20 pounds of carbon dioxide for every gallon of gasoline burned. Write and graph a function that describes the relationship. Okay, so we know the car is producing 20 pounds of carbon dioxide per every 1 gallon of gasoline. So let's figure out the words we need to use. Okay, how many pounds carbon dioxide?
20.
And it equals the pounds per gallon times the gasoline we've used. Okay, so pounds for P, G for gallons, that makes sense?
Yes.
So our equation is P equals a number times gallons. Well, it says it uses 20 pounds for every gallon, so that's why you put a 20 there. Okay, so P equals 20G. See it right here? So that's the equation we've put. It says write and graph it. So now we just need to graph it. Can I just graph this? Do I need to do all this ordered pair stuff?
No.
You don't have to. You can just graph it. This is Y, this is X, so we start at 0, and then we go up 20 over 1. Okay, if I would just pick... How come they didn't pick any 0 or negative numbers? Because it's a real-life problem. You can't have negative amount of gas.
Oh, yeah.
Well, burn your gas.
It's not good. It blows up your engine. Trust me, don't do it. Okay? So they put in 1, 2, 3. So 20 times 1 would be the output of 20.
Whoa.
So 120. Put in a 2, 40, 140, or 240. Put in a 3, 60, 360. So these are 3 ordered pairs we could graph. See them graphed? Now again, I could have just started at 0, 0, gone up 20 over 1, and still had the same graph. Okay? So, again, because you cannot burn negative number of gallons of gasoline, you only use positive values. We discussed that already.
Yeah.
Whoa, so smart.
Okay? So there's your graph. So if I were to ask you how much carbon dioxide was produced after I burned 3 gallons of gasoline, could you tell me?
Yes.
How many?
60.
60. What if I burned 4 gallons of gasoline?
80.
80. Does this make sense?
Yes.
Excellent. All right. You may finish all the way through 18. This is due Monday, so if you have not finished it by the end of today, just do it over the weekend. It is due Monday.